Greetings and welcome to Section 4.5 Solving Polynomial Equations, Part 2. So we've been talking a lot about solving polynomial equations when they were factorable. And that, of course, is the easiest way to solve any polynomial equation. The easiest way is by factoring. So if you can't factor, though, we do have other methods that we can use. We have something called the rational root theorem. Rational root theorem says if, this junk right here, that just means if it's a polynomial. It's got to be a polynomial, and it has to have integer coefficients. We don't see any fractions as coefficients. And if that's true, then every solution to the equation has the following form. And it's written as a fraction. That's what a rational number is. Remember, a rational number is a number that can be written as a fraction. And the fraction number on the top is always a factor of the constant term, right? That number that's at the end that you don't have a variable next to. So it's a factor of the constant term over a factor of the leading coefficient being the first number. So this is pretty important. Some very smart people spend a lot of time proving that this is true, so it's something that we can actually utilize when we have a polynomial that we cannot solve by factor. So when we get to this next one right here, we're going to find all the possible solutions for this equation. And if you look at this, you'll actually see that this is in fact not factorable. You can't do anything, right? There's no term here that you can pull out. You can pull out an x squared out of this term, and then you're left with x minus 8, right? But then when you get to this second part right here, right, what do they have in common? Like a 1? So then that gives you 11x plus 20, right? And if we're trying to factor it, you'll see that this parenthesis and this parenthesis don't match. So we're actually not able to factor those at all because of that, because those parentheses have to match if we were going to solve it by factoring it. So since we can't solve it by factoring it, we're going to have to go a different method. And that's where the rational root theorem comes in. So the first thing that we have to do when we look at this and use the rational root theorem is we have to identify what P is, and we have to identify what Q is. Now, P is going to be this number right here down at the end, the 20. Okay? And then Q is going to be this number that's right here at the beginning, right? The leading coefficient, so 1. So again, using the rational root theorem, what we have to do is we have to look at all the possible factors of 20. So let's see, what is that? That's 1, 2, not 3, but 4, 5, 10, 20. These are all factors of 20. We can't forget the negatives, so in front of each of these, it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and plus or minus 10, and plus or minus 20. Now, thank goodness this one is easier because there's only one factor of 1. So now, in order to figure out what our possible solutions are, right, our possible solutions are going to be every possible value of P, factor of P, over every possible factor of Q. So we're going to start writing out that list, and it's going to be a very long list. So here we go. Possible solutions. So we know x can equal plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 5 over 1, plus or minus 10 over 1, plus or minus 20 over 1. Oops. Let me fix that, make that look like an actual 1. There we go. That's much better. Now, I don't necessarily like the format that these answers are in. I would like them to be simplified down a little bit more. So if I did that actually, if we did the math there, we'd simplify it down. We'd get x equals, once we simplify those numbers down, as plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. And those would be my possible answers for that polynomial I had. All right, this one is a little bit more challenging because you'll see when we have different values for P and Q. So let's start. Let's see here. P is 12 and Q is 10. So we're going to list out all the possible factors of 12. So let's say that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And we did the same thing again with 10. So let's say that's plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Man, I'm getting tired of saying the plus or minus, but it's there in every single one. So now, when I list all my possible roots, right? All my possible roots, it's every possible factor of P over every possible factor of Q. So when I'm looking at my possible roots are going to be, man, this list is going to be long. So let's see here. It'll be, let's see here, 1 over 1, right? So 1 over that one. If it's not that one, then it's 2 over 1, right? This 2 over this one. And then what? 3 over 1, right? This 3 over this one. 4 over 1. 6 over 1. And 12 over 1. Wow. Then we got to go back through again, right? We got to go back through again, and I got to repeat the same thing again. So let's see here. But this time it's going to be 1, that one, over the next value, 2, right? And then we're going to do 2 over 2. And then the next one, right? 3 over 2. And we keep going on and on. 4 over 2, 6 over 2, 12 over 2. Oh, man. Just when you think you're done, you got to go and do it again. You got to do each one of these values over 5. So we do plus or minus 1 over 5, 2 over 5, 3 over 5, 4 over 5, 6 over 5, and 12 over 5. Wow, that's a lot. Then we got to do it one more time and put them all over 10. So let me show you what that actual list looks like when we're all said and done here. Alright guys, so here's the list of everything. So you'll see that it's plus or minus 1, 2, 3, 4, 6, 12, 1 half, 3 halves, 1 fifth, 2 fifths, 3 fifths, 4 fifths, 6 fifths, 12 fifths, 1 tenth, and 3 tenths. So what I did was I did a couple things. I first of all eliminated all of my repeats. So in the previous list you saw, for example, 2 over 2. Well, 2 over 2 simplifies down to 1. I don't need to write that twice. Likewise, when I got to my tenths, 2 tenths would have been written down, but 2 tenths simplifies down to 1 fifth, and I don't need to write 1 fifth more than one time. So this is a complete list of all of the answers. Let's do 2 other problems. So what I'd like you all to do right now is I'd like you to pause the video right now, and I'd like you to try example C and example D on your own, please. So pause the video and try example C and D on your own. And here they are. Here are the answers to C and D, so hopefully you were able to get those on your own. If you need to, you can of course go back and look at the notes that I've posted online. I do have some work for these problems, even though I'm not going to do it here in this video, but just check that out. So we're going to change gears a little bit here. And instead of finding all the possible answers, we're actually going to go through the process of finding what the actual solutions are. So once we have our list here, right? Once we have our list here, we know that one of those is a possible answer to the value of x in our equation, x to the third minus 8x squared plus 11x plus 20. And we're now going to go through the process of trying to figure out which one it is. So this list up here is 12 different possible answers that we could come up with. So really what we're going to do is we're going to guess and check. We're going to guess and try to guess which answer we think is it, and we're going to test it out with the problem. Now, my suggestion to you would be to start with a smaller number. So I think starting down here at the 1s is a smarter idea than starting up here at the 20s, because you really don't want to start up there so much. So the first number that I'm going to try is I'm going to try 1. And what I mean by trying it is I'm going to actually do synthetic division with the number 1. So let's see here. I'll set up my synthetic division. And then what I'm going to do is I'm going to actually do the synthetic division with the number 1. So let's see here. Bring down the first value. Then I got 1 times 1, which is 1. I add them together. I get negative 7. Then 1 times negative 7 is a negative 7. Add 11 and negative 7, and I get 4. Then I do 1 times 4, and I get 4. And when I add those together, I get 24. Well, that's not 0. Okay, and since it's not 0, that means that 1 is not a possible solution. Okay, so what's that mean? Well, that means it's time to try something different. So I'm going to erase all this here. Okay, and instead of trying 1, what I'm going to try is I'm going to try a different value. So what value should I try? Let's see here. Well, 1 didn't work, but maybe, just maybe, negative 1 will. So I'm going to go through the same exact process I just did, but I'm going to use negative 1 instead of positive 1. So I say bring down the 1. Negative 1 times negative 1 is a negative 1. Negative 8 plus negative 1 is a negative 9. Negative 1 times negative 9 is 9. 11 plus 9 is 20. And negative 1 times 20 is negative 20. And look here. That is equal to 0. So yes. That means that negative 1 is a possible solution. So x equals negative 1 is a solution. It also means that x plus 1 is a factor. And that's very good news. If that's a factor, then that means I can take my polynomial, which was x to the third minus 8x squared plus 11x plus 20, and that means that the x plus 1 that I just found out is a factor is in fact a factor of something, and I can write that out in a factored form. And if you remember what it was on the other screen when I did that synthetic division, it was x squared minus 9x plus 20. That was left over after I divided out the x plus 1. Well, that is in fact factorable as well. So numbers that multiply together give you 20, add together to give you negative 9. That's 4 and 5. So if I set each one of these factors equal to 0, I come up with my solutions. Negative 1, 4, and 5. And that is pretty awesome. Okay, so at this point I'd like you guys to pause the video again and try this example C. Yes, I know I skipped over B and there's a reason for that. Try example C here, which we did earlier and got these possible solutions right here. We got those possible solutions right here. So try it out, see what you come up with. The answer will be here momentarily. So pause the video, try it out. So here you go for example C. I tried negative 2. I found that negative 2 did in fact work. You see we got a remainder of 0 there, which means that x plus 2 is a factor. So it's x plus 2 times x squared minus x minus 12, which you can factor down to give you x minus 4 times x plus 3. We end up with our final answers of negative 2, negative 3, and 4. So I thought for this one we'd get a little help, and by a little help I mean I thought we'd look at another way to solve this. So what we're going to do is we're going to take a look at the graph. So I've taken this expression and I've plugged it into Desmos, and here's the graph we came up with. So here's the equation. I've plugged it in, and you'll see we have some zeros here, which are the same things as the solutions. You'll see there's 4 of them. There's 4 solutions here. So, man, I just don't know what they are. But if I compare that to my list of rational roots, I might be able to make and be able to narrow down that list a little. So if you look here, like I see over here on the left point, what could they be? That could be negative 1/2, maybe it's negative 1/3, maybe it's negative 2/3. I'm not real sure which one it is, but I can pick one of those pretty intelligently. Or what about this guy? That 1/2, I'm feeling pretty good about 1/2 there. Maybe 1/3, maybe 2/3, but doubtful. I'm feeling really good about x equals 1/2 here for that particular value. What about this guy over here? Man, nothing showed up in my list that's over there. That's kind of weird. We'll have to check out to see what happens over there. Hopefully it'll come out when we do the math. Okay, so based upon what we saw, I felt pretty good about 1/2. So I'm going to do my synthetic division with 1/2. And yes, you can use fractions with synthetic division. The rules don't change. So I'll bring down my 6, and then I'll do 1/2 times 6. I'll add 11 and 3. I'll do 1/2 times negative 8. I'll add negative 16 and negative 4. Again, multiplying, adding, and multiplying, and hey, I was right on. Look there. I did in fact get a remainder of 0, which means 1/2 works. Now, what I'm looking at here is I know then that x minus 1/2 is a factor of that polynomial, that 6x to the 4th polynomial. So, but what I have left over is not what I had left over before. This is a different polynomial. So if you look at it, oops, it's a squared minus 20x minus 8, you'll see that I actually have something that's here to the 3rd power instead of to the 2nd power. So that means that I have to do more. I have to continue going. So let's take a look at what I got to do next. So if I look at what I have left over, I got x minus 2, but then I have this other polynomial like I told you back on the previous slide. So what I have to do now is I have to do this whole process over again with the 6x to the 3rd minus 8x squared minus 20x minus 8. To do the whole thing over means that I could come up with a new list of rational roots. I could go through that whole process, but the graph really helps me in this particular instance. And I told you I was feeling really good about negative 2/3. I thought maybe negative 2/3 was another value that I could use. Now, I'm not going to go back to the original polynomial. Instead, I'm going to use this polynomial up there. So I'll have my 6, my negative 8, my negative 20, and my negative 8. I'm going to go through and do the process of synthetic division again using these numbers. So let's see here. Okay. And then I multiply that and I get positive 8, and I got a remainder of 0. So that's really good news that I got a remainder of 0 again. So this helps me keep going and able to factor just a little bit more. Okay, so I know that 1/2 works. I found that out. And then I found out that negative 2/3 works. So that means that I'm left here with 6x squared minus 12x plus 12. And if you notice, every single one of those numbers is divisible by 12, or 6. Divisible by 6, so I'm going to pull out a factor of 6, and that'll leave me left over with x squared minus 2x minus 2. So let's see here. There you go, right there. There's my x equals 1/2 as a solution. There's my x equals negative 2/3 as a solution, and all I got to do is factor that. Oh no, but wait. X squared minus 2x minus 2 is not factorable. So how in the world do I solve x squared minus 2x minus 2? Well, I'm going to set it equal to 0, and then guess what? Quadratic formula. So if you trust me on this and you do the math with the quadratic formula, you will get 2 plus or minus the square root of 12 over 2, which you can simplify down to get you 2 plus or minus 2 root 3 over 2. Which simplifies down to 1 plus or minus the square root of 3. So we go from our original equation here to the factored form here, where we're able to come up with the solutions of 1/2, negative 2/3, and 1 plus the square root of 3, and 1 minus the square root of 3. If we go back and look at our graph again, you will see that these are the points that we found to begin with. Now, go check out that homework. See ya.